Plate tectonics could be incredibly rare, and so could life. Lego bricks made from actual space rocks, mapping the Milky Way's dark matter halo, and Perseverance's SHERLOC instrument is fully operational again. All this and more in this week's Space Bites. Why did life form on Earth? Now, obviously, if life hadn't formed here on Earth, we couldn't even be here to ask this question, but what were the factors that contributed to the existence of life on Earth? A few are obvious, like we needed a star, we need solid ground under our feet, we need the raw materials, we need the various organic materials to be able to form life, we need liquid water on the surface of our planet, as well as like an atmosphere to hold our juices in. That's a good way to describe it, isn't it? Our fluids in, so we don't boil away. But there could be a much larger list of things that life needed. For example, what about a large moon to keep the axial tilt of Earth stationary? And one that scientists wonder about is plate tectonics. How important was the rise of plate tectonics to the evolution of multicellular organisms on Earth? There's like a weird coincidence that multicellular life arrived on Earth about 600 million years ago, roughly the same time that plate tectonics appeared on Earth. Now, plate tectonics could have many influences on life on Earth. For example, increased nutrients available to life forms, sped up oxygenation in both the water and in the atmosphere, a tempered climate, high turnover rate of habitat, and increased environmental pressure that might push organisms to face greater challenges. So geologists were looking into how likely are plate tectonics to form on a planet that is within the habitable zone of its parent star. And when you look at other worlds in the solar system with volcanism, we've got Venus, we've got Mars, we've got Io, the moon had volcanism in the past, and yet Earth is the only one with plate tectonics. They ran their simulations and found a range of results for like how likely plate tectonics are to appear on terrestrial planets. And on the high end, you get 0.2% of worlds. And on the low end, they found it would be 0.003% of worlds could have plate tectonics. And so Earth might actually be incredibly rare, and having plate tectonics might have been one of the keys to us having more complex life forms that we have today. We wouldn't be here without those ancestors. We're finally learning about the OSIRIS-REx samples. Now, we've been reporting on the OSIRIS-REx mission for years. I watched the launch of this rocket. We've seen the return of the capsule, and we talked about how difficult it was for NASA to actually open up the capsule. Well, they got it figured out, and they have handed samples out to researchers around the world. And we've learned a little bit of really interesting stuff about what the spacecraft returned. The largest sample is about 3.5 centimeters across, so like a tiny little rock. Most of it is just dust, and most of the material is incredibly dark, although it does have some like veins and other kinds of inclusions of lighter material. It appears to be primordial, and so this is not the result of an asteroid that crashed into another asteroid, was heated up, melted, crashed into something else, heated up, melted. No, this is something that just formed left over from the original material in the solar system. And the most intriguing possibility is that it was in the presence of water for a long time. When examining the samples, researchers found that the rocks are similar to the kinds of rocks that we have at the mid-ocean ridges. Speaking of plate tectonics, and we're seeing minerals like serpentine and various clay materials that would be in the presence of water. The way they describe it is that this suggests a watery past. So maybe it was a larger world that was covered in water and then broke up over time. So the mystery deepens. It's really interesting what they're finding with OSIRIS-REx. Finally, fast internet for the International Space Station. Now, one of the problems with the International Space Station is that it doesn't have very fast internet. You always hear stories about astronauts who are taking their Blu-rays and DVDs to the space station, and you've got like a library of movies that the astronauts can watch, because transferring data to and from the International Space Station is actually pretty expensive. They don't have a lot of bandwidth to work in, and they normally have to reserve it for their science work or personal communications from the astronauts. But NASA has been testing out a method that will provide a much faster internet service to the station. They've launched a prototype satellite into a geosynchronous orbit. And then what they do is they gather up all the data to send to the astronauts on Earth. They beam it up to the satellite relays it back to the station using a laser. In a recent test, they were able to get 1.2 gigabits per second in transfer speed to the International Space Station. They sent a care package of pet photos and videos from people at NASA to the astronauts on the International Space Station, which would normally be considered an enormous waste of bandwidth. And yet, because they have so much bandwidth, they're running this test, they're able to send us. And so I think, you're starting to see this increased infrastructure in space exploration. And that's a really good sign, because it shows that we're going to space and we're going there to stay. Lego bricks out of space rocks. Now, we talk a lot about in situ resource utilization, living off the land. When we go to the moon, we're going to be limited by how much material we can bring from Earth. And so we want to try and use as many of our resources as possible out of the local material that's there. And what do you have a lot of on the moon? Rock, crushed up powdered rock called regolith. But what are going to be the various techniques to actually turn this into usable structures? And so engineers on Earth at the European Space Agency were using 3D printers. Normally they use a regolith simulant, something that is kind of like the regolith, but made out of various materials that we have here on Earth. But they went one step further. They took an actual meteorite that had been found in Africa in the year 2000, and they crushed it up. And then they used that as part of the mix for running their 3D printer. And then what they made were Lego bricks. And if you look at a very high resolution, you can see how the 3D printer was laying out the structure of the bricks. But apparently these things actually can be connected together. They're clearly a lot rougher and probably pretty hard to put together and pull apart. And so as some kind of cooperative marketing opportunity with Lego, they are going to be showing off some of these Lego bricks in various Lego stores around the world. And obviously this is a PR stunt, but I think it's pretty cool. Every week we do a vote on our channel where you tell us what you thought was the top space news story of the week. We didn't put the option to vote on the bear that booped my camera, and obviously that would have been the clear winner last week. And a lot of people were complaining about that, and we only have a limited number of options. So obviously that's the winner, the unofficial winner. But according to the poll, the winner was the return of the Chinese Chang'e 6 lunar samples, which are now being opened up, and they're going to start to be investigated as well. So thank you everybody who voted. Now we will post the next vote into the community tab on our channel within about 24 hours of when you see this video. So if you don't just see it while you're scrolling randomly on YouTube, you want to find it, go to the community tab. But of course, the best way to find us is to subscribe to our channel, click on the notifications bell, watch a bunch of our videos, train the algorithm to show you our content. Mapping the Milky Way's dark matter halo. We can look out into the universe and we see lots of different galaxies. We can see spirals and dwarf galaxies and giant elliptical galaxies, but it's really hard to figure out the shape and structure of the galaxy that we are embedded inside, the Milky Way. But through painstaking work, astronomers have been able to measure the shape and structure of the Milky Way and try and figure out, what kind of spiral galaxy are we in? What are the twins of the Milky Way as we look out into the universe? In the last couple of years, some really interesting research has shown that in fact, the Milky Way's disk isn't just this nice flattened plate that's spinning, but it actually has a warp to it. And now astronomers have been able to map out the dark matter halo that is surrounding the Milky Way. And I know that sounds even more difficult. How do you map a thing that is invisible? So you have to map out the effects of the gravity of the dark matter on the Milky Way. So astronomers in China looked at Gaia data for 2,600 Cepheid variable stars. And these are a very specific class of stars. We talk about them all the time. They're used as standard candles, a way to figure out the exact distance to a star. And they had this giant catalog of these in Gaia data so they could measure their distance and their motion. And by knowing their motion, they could figure out what their motion looked like over time into the past. And based on this Gaia data, they were able to look into the past and calculate how the shape of the dark matter halo surrounds the Milky Way. And they found some really surprising things. So it is not a perfect sphere. It's actually an oblate spheroid, kind of like the way the Earth is a flattened sphere. And then they also found that it precesses in a retrograde motion over time. So again, imagine you've got the Earth. The Earth is an oblate spheroid and the Earth is spinning on its axis, but actually its axis is wobbling a tiny little bit. And so the dark matter halo that surrounds the Milky Way is doing the same thing. It is turning, it's slightly flattened, and it is precessing on its axis like a top that is running out of energy. Basketball-sized meteorites are hitting Mars every day. Now, I know a lot of people want to go and live on Mars, and if you do, just watch your head, because it appears that there are space rocks falling to the surface every single day. And that isn't a surprise. Like here on Earth, we have this very thick atmosphere, and that protects us from all but the largest meteors that are striking the Earth's atmosphere. Without that thick atmosphere on Mars, space rocks are making it all the way down to the surface. And so scientists use data from NASA's Mars InSight spacecraft to track the number of impact events that were happening around it. It was designed to look for seismic activity, detect the Mars quakes, but also it detected about 70 of these impacts onto the surface of Mars. And then orbital spacecraft were able to confirm the craters that had been created by some of those impacts that InSight detected. And when they extrapolated on that data, they estimated that between 280 and 360 basketball-sized space rocks smash into the surface of Mars every year. So about one a day. And these carve out about an 8-meter crater on the surface of Mars. But then the bigger ones are happening too. But once a month, a 30-meter crater is carved out on the surface of Mars. And that rate is about 5 times as much as had been previously estimated based on orbital imagery. So watch your head. Lunar swirls from cooling magma. One ongoing mystery about the moon are these strange lunar swirls on the surface. These are lighter in color, they can extend for dozens of kilometers on the lunar surface, and they appear to be caused by some kind of interaction with magnetism on the moon and particles from the solar wind that are being channeled down, and they're striking the surface of the moon in these very strange shapes. And astronomers thought that these were caused by old impact sites, that you had some rock that crashed into the moon and you got a region of localized magnetism that then you had this solar activity was causing these swirls around the impact site. But a new simulation showed that in fact you could explain this with magma under the surface of the moon that is cooling down over time. As the magma is cooling down, the particles are aligning and you're getting this magnetism that is extending out from this cooling magma beyond the surface of the moon that is then channeling these particles down. So, this might not be the definitive answer. The mystery continues, and yet it's really cool to think how active the moon might still be. SHERLOC is fixed. NASA's Perseverance rover hasn't been able to use one of its main instruments for about 6 months now. The instrument consists of a laser spectrometer and 2 cameras that it uses to scan rocks for evidence of organic compounds. And this is one of the main reasons why Perseverance is on Mars, is to try and find evidence of organic compounds on Mars that have been there billions of years ago, or maybe even now, that could indicate that there was life or the byproducts of life or something. And so it sucked that Perseverance wasn't able to use this instrument. And there was a couple of problems. One is that the sort of focusing system for one of the cameras wasn't functioning. The other problem was that the lens cap in front of the system wasn't able to deploy, so it was constantly blocking the view. And so NASA engineers have been troubleshooting the problem. And so they tried different ideas, like they tried to heat up the motor to see if it was maybe seizing up. And then they tried tilting the lens cap around and opening it and closing it. And then finally they did this, but they also were engaging the drill on this arm that sort of shook it while it was doing that. And after all of this work, they were able to get it to fully open 180 degrees. The second problem is the camera. And what they found is they can get around this camera problem by just being very careful about how far away from their target they hold. So essentially they are using man, what's the term? We used to, like, feet focus? I'm trying to remember what we used to call this. You focus with your feet. Anyway, they found that if they got within 40 millimeters of the surface, then the camera was in perfect focus and they were able to get good scientific data from it. So SHERLOC is operational again. The Kuiper belt is bigger than we thought. The Kuiper belt is this region in the outer solar system. Pluto is orbiting inside of it, Eris. It's a region where you've got icy objects left over from the formation of the solar system. And it's thought that the Kuiper belt ended at around 50 astronomical units away from the sun. But NASA's New Horizons spacecraft is way out beyond that area. And recently it was still detecting icy particles onto its sensors, which led planetary scientists to think, okay, maybe the Kuiper belt is bigger than we thought, or maybe there's even a second Kuiper belt out there that now New Horizons is flying through. And so astronomers here on Earth have been able to do some observations that confirm this theory. They use the Subaru telescope. They're able to find a couple of Kuiper belt objects that are on orbits that carry them farther out into the solar system, out beyond the distance of the Kuiper belt. And it could very well be that the Kuiper belt is actually dramatically larger than we had originally thought. And this is important because as we look out into the universe and we look at other exoplanets and we see the Kuiper belts that are orbiting around these other exoplanets, that gives us a sense of how much material they had to work with when they formed, and that can tell us how much ice, water we could expect to find in the inner solar systems of those exoplanetary systems. So once we get a good sense of how big the Kuiper belt is, and we know how much water we have in the solar system, that's a way to then compare to other systems out there. Polaris Dawn will be flying at the end of July. A couple of months ago, we talked about the next generation SpaceX suits. These will allow their astronauts to actually be able to perform a spacewalk. They won't have a bulky backpack, but they will have a tether that attaches them to the spacecraft. And so we've learned that the Polaris Dawn is due to launch in July 31st. This will carry a crew of private astronauts into low Earth orbit for 5 days, where they're going to spend time orbiting around the Earth, and they're going to try out the first private spacewalk using these new spacesuits from SpaceX. And around that time, we should expect to see the next test launch of Starship. And this time around, the hope is to actually be able to catch the Super Heavy booster back at the launch platform with Mechazilla with the big chopsticks. So stay tuned for that. And as always, I like to wrap up these episodes of Space Bites with some really cool pictures and videos. So first up, this is an image of the newly forming star L1527 captured by James Webb Space Telescope. And this is a class of protostar that is about 100,000 years old. And we're seeing this star edge on. And so you can see these funnels on the top and the bottoms of the star. Now, normally you wouldn't be able to see this at all. Like, this is enshrouded in a cloud of gas and dust. But because James Webb is able to see through the gas and dust, you can actually see that newly forming star at the middle. And you can see how all of this material is getting funneled down into the star to help feed and help it grow. Over time, the star will fully ignite, and then its radiation will start to blast out. And instead of having material coming in, it will actually get these jets that start to form out of the poles, starting to blast material away from the star. It will clear out its environment. It'll form any planets that it's going to form, and then it will just be a regular star, the kind of thing that we see in the sky. But this is right at the very beginning of a new star. And then we got one of the most beautiful videos of a rocket launch that I've ever seen. This is a video of a SpaceX Falcon 9 rocket that's carrying a payload for the National Reconnaissance Office. So I don't, it's classified, but just like the colors as it's going up through the cloud tops. I'm not even sure how they took this, probably a drone or something, but the video is absolutely amazing. SpaceX said this is just a raw video, didn't do any processing on it, but it's really incredible. And finally, here's a video of a barred owl on my property who is getting harassed by robins nonstop. And we hear this all day long. We hear robins just chirping at owls because they're so angry. And if you actually look, you can see one of the robins goes right through his feathers on his head, and the owl is just staring at me. It was amazing. Now, you're watching Space Bites, but as you're watching, I'm writing this week's weekly email newsletter, which has so many more stories than what we talked about here today. For example, what's next for the Event Horizon Telescope? 12 more supermassive black holes that we could find more information about. An interview with Dr. David Kipping about exomoons, and how a concentrated beam of particles and photons could push us to Proxima Centauri. Now, you can go and sign up for my weekly email newsletter. It comes out on Fridays to more than 70,000 people. I write every word. There's no ads. You can unsubscribe anytime you want. Go to universetoday.com/newsletter. Completely free. I'm going to talk about amazing spacecraft recoveries, but first I'd like to thank our patrons. A special thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. This story with SHERLOC is great, and this is the kinds of stories that I really enjoy with space exploration, when there's a problem and yet engineers figure out amazing solutions to the problem, they troubleshoot through it, and they come up with a solution. We saw this with the Voyager spacecraft, how it was sending back garbled data and they were able to like reprogram whole chunks of its memory to be able to communicate with it. But I think the greatest example of spacecraft recovery is with the Kepler spacecraft. And for those of you who aren't aware of this story, the Kepler spacecraft was designed to be the one that would find Earth 2.0. It would stare at one chunk of the sky for a long period of time, rock solid, and then spot the transiting exoplanets that were passing in front of them. But before it was able to complete its job, a lot of its reaction wheels failed, so it was no longer to maintain its lock onto its target. And so, would the spacecraft be lost? Engineers at NASA figured out that they could use the light pressure coming from the sun as a way to balance the spacecraft so they could have it be able to stare at other regions in space. They weren't able to do this full, long, find another Earth mission, but they were able to find a whole bunch of exoplanets orbiting around red dwarf stars. And in fact, still, Kepler turned out to be the most productive planet hunter that has ever been launched. And so, and there are so many of these stories. I should really do a series at some point because there's just so many amazing recoveries of spacecraft over time. All right. Hope you enjoyed this week's space news. We'll see you next week.